So today I'm experimenting with infrared sensor technology. And so here I have a setup where there's an infrared sensor. That guy right there. It's actually a flame sensor, but it functions like an infrared sensor. It does provide some voltage from ambient light, but I have it set up so that it's powered to the short leg, and then the long leg goes to ground through a 10K resistor. Then I have a separate power and ground to resistor for one of these gizmos, which is an infrared transmitter. I don't have an infrared LED light, but I'm going to try with this first. And the way it's set up is that the signal comes out through the grounded leg, the long leg of the infrared sensor, and it goes through this wire right here to the non-inverting input of a LM324 opamp. Then the reference voltage, which is going to the inverting input of the LM324 opamp, is coming from this potentiometer, which one side is going to the positive rail, one side is going to ground, and it's a 1K potentiometer. And this is just to adjust the reference voltage so that the LED doesn't just light up from ambient light, which it will do if you turn it down far enough. If you go down towards ground, let me get it in there better, it will turn on. So the key is to get it to turn off from whatever ambient light is going on. That way, the op-amp functions as a comparator, and the output of the comparator goes to this LED, which is going to ground through a 1K resistor, rate limiting resistor, or current limiting resistor. Don't mind the transistor back there, that's not doing anything. And so I have it all set up going to a voltage meter. And this is measuring the current voltage that's going into the non-inverting input from just the ambient light in the room from this infrared sensor. And at first, just to prove the concept, I have here a remote control, which has infrared transmitters on top, and that's how it works. So if I shine this remote control on this infrared sensor, the LED should light up, and it does. Whatever button I push, it's just whatever frequency encoding is going on with that remote, with the transmitter of the remote control. All right, so now, next step is to get it to work with this gizmo. And so, as I get this closer to the IR sensor, the light goes on. If I take it off, it goes off. And as I do this, this is the current voltage with the LED off. And as I bring this closer and get the LED to come on, it goes all the way up to 4 volts. And the LED is on. And the range on it is about here. If I go higher than that, it goes off. So the reason I'm doing this is try to see if I can get this to, if I flip it over and try to get things to reflect off of it, and then bounce back to the receiver, it seems to work. So seems to work fairly well. but it's not as good at reflecting as I thought it would be. Maybe I should get a better light, or a more powerful transmitter, or just put more voltage to the transmitter. That remains to be seen in another experiment. But what's interesting about this is if I just put this down and I crank down the potentiometer to the point where the light is lit or activated just by active lighting, room light for instance, here you go, and then all I have to do is just block the ambient light, and this functions like a photoresistor, and all I have to do is wave my hand over it, and it turns off. And I wonder if that's a better way to get it to function. If somebody can maybe help me out with that idea, to get it to work better. The whole purpose is to use it with that anemometer right there, and have it underneath. However, I have too many variables using this, and this is instead of using a Hall sensor to get the analog output of the anemometer in terms of measuring the RPMs and measuring wind speed. So at the moment, this seems like a much more functional way of doing it than trying to get it to reflect off the spokes of the anemometer as it rotates. But the infrared sensor does work very nicely when it's directly transmitting. And the voltage produced is fairly good. Almost 90% of VCC. That's pretty good. So, but when I use it as a reflective surface, it doesn't work so well. If I try to just stick this near it, it somehow just transmits. Maybe I'll test it out, but definitely works well. So now it's all stayed lit. That means the potentiometer needs to be turned. Yep. But now, we'll turn it a little bit more just to get it to be off. And the remote control works very well for it. If I had an oscilloscope, I could actually decode all these frequencies, make my own IR remote. And each one each button functions at a different frequency, it seems like. You guys could see that well. Anyway, the saga continues, trying to find the best way to measure RPMs as a counter, using a counter circuit that I've designed previously that I'm going to implement once I get some kind of adequate sensor. And I'm still thinking the Hall effect sensor will be better for this, but nevertheless, just experimenting. Thanks for watching.